Assalamualaikum and hi everyone. We are from Group 3. So, we are going to present about our topic, momentum. It consists of impulse, also, elastic impact, and inelastic impact. Okay, first, we look at impulse. And our team members are Muhammad Amirul Ashraf bin Jaman Huri, Wan Izwanis Izzuddin binti Wan Ubaidillah, Nur Irene binti Muhammad Nazri, and Nur Shazwani binti Simsuddin. So now, what is impulse? Impulse is the product of constant force and time. Multiplying force in unit Newton and time in unit second, we will get impulse with unit Newton second or kg ms power of -1. Impulse is a vector quantity where the direction of impulse is in the same direction of the action force. If force move to the left, impulse move to the left. If force move to the right, impulse also move to the right. Next, we go to impulse momentum theorem. This is the relationship between impulse and momentum. The impulse momentum theorem states that the change in momentum of an object equals the impulse applied to it, which is J equal to the change of P, which is momentum. How can it be like that? The impulse we can write as Ft, and momentum we can write as the change of P. We can derive this formula into another formula. If the mass is constant, we can write our formula as Ft is equal to mv. F for force, T for time, m for mass, and v for velocity. And our m, our mass, since it's constant, we only have one value. For v, we can have two values, which is velocity final minus velocity initial. Next, we move to impulse and Newton's second law. The impulse momentum theorem is logically equivalent to Newton's second law of motion, which is the force law. When Newton's second law is expressed in terms of momentum, since P is equal to mv, mass is assumed to be constant. F equal to ma is actually derived from the equation F equal to P over T. The relationship between Newton's second law in its two forms, let's recreate the derivation of F equal to ma from F equal to P over T by substituting the definition of acceleration and momentum. The change in momentum P is given by P equal to mv. If the mass of the system is constant, then mv equal to m with the change of v. By substituting m with the change of v for P, Newton's second law of motion becomes F is equal to mv over T. Since A is equal to v over T, we can substitute to get the familiar equation for Newton's second law, which is F is equal to ma when the mass of the system is constant. In application of impulse, we can see at effect of collision time upon the force. For effect of collision time upon the force, first we have formula Ft is equal to P when we bring T to the right side, and we will get F is equal to P over T. And it shows that force and time are inversely proportional. So, we can see that the greater the time over which the collision occurs, the smaller the force acting upon the object. Thus, to minimize the effect of the force on an object involved in a collision, the time must be increased. And to maximize the effect of the force on an object involved in a collision, the time must be decreased. Application in real world, we can see at airbags and egg drop experiment. To get a clear picture about these applications, let's watch these videos.